Alright guys, good morning. Welcome. Hope you had a nice day off yesterday. We're going to continue on with circles today. So in 12.1 we looked at just reviewing just some basic properties of circles, some pieces inside a circle. You got your center point, your radius, your diameter, your tangent, your secant, your chord, all of those different pieces. So today we're going to kind of continue on. We're going to focus a little bit more on angles and more specifically the central angle and then different types of arcs. All right, now the first thing we're going to look at or just kind of talk about some of the vocabulary are minor arcs and major arc. Now, an arc is just a piece of the outside of the circle. So if you just kind of scroll down and look down here at these circle examples, this green line right here, this dark green, this would be arc ACB. It's just a piece of the circle. All right, this small one would be arc AB. All right, so a minor arc, though, more specifically, I'm just going to type this up so you guys can hopefully read it a little bit better than my handwriting. A minor arc is just an arc whose measure is less than 180 degrees. All right, so if you know, you guys remember, a circle is 360 degrees, so half of it would be 180 degrees. So if you've got an arc that is less than 180 degrees, that's going to be a minor arc. So less than half the circle. Now, similarly, you've got a major arc. If you guys kind of think minor is less than 180, a major arc is an arc whose measure is more than 180 degrees. All right, so that's going to be a major arc. So again, minor arc is an arc whose measure is less than 180 degrees. A major arc is one whose measure is more than 180 degrees, so more than half the circle. So if you guys look back down here towards this example that we were looking at just a second ago, arc ACB, if you notice, that covers more than half the circle, so that would be considered a major arc. And then arc AB, this small arc right here, this one that's not highlighted or not darkened, that would be a minor arc. That's less than 180 degrees, so it would be considered a minor arc. All right, now the next one we're going to look at is a semicircle. Now, a semicircle is an arc whose measure is equal to 180. Arc whose measure is equal to 180 degrees. Not 189, but 180. There we go. All right, so a semicircle's arc whose measure is equal to 180 degrees. So it is exactly half of the circle. So if I was looking down here at this example, once again, this arc right here, arc AC. All right, let me just take this and we'll highlight here. So this arc right here, arc AC. If you notice, segment AC is the diameter. That's exactly half the circle. It cuts the circle in half. It goes through the center point. It's a chord that goes to the center. So if that's the diameter, segment AC, then arc AC is going to be a semicircle. It's exactly half the circle. All right, so if the whole circle is 360, then exactly half will be 180 degrees. All right, so that's a semicircle. So once again, minor arc, arc whose measure is less than 180 degrees. Major arc is more than 180 degrees. And a semicircle is one that's equal to 180 degrees. All right, one of the last little vocab pieces we're going to look at today is a central angle. Now we're going to look specifically at an angle. All right. Now let me just erase what we just did a second ago. All right. Now a central angle, and it kind of makes it pretty self-explanatory, is an angle whose vertex is located at the center. And we'll expand this. We'll say the center of the circle. All right, so again, a central angle is an angle whose vertex is located at the center of the circle. So if we're looking back down here, example, once again. All right, once again, we've got, let's get something here. All right, so my central angle, it kind of has it labeled here. If I were to be talking about angle ADB, notice the vertex of that angle is located at the center, which means angle ADB would be considered a central angle. Now, the arc it opens up to is called its intercepted arc. So arc AB right here would be the intercepted arc, and angle ADB would be my central angle. Now, that's really what we're going to be focusing on today, are central angles, minor arcs, and major arcs. We're going to be looking at their degree measures and everything like that. All right, now measuring arcs. All right, this first piece was going to be dealing with the central angle and its intercepted arc. And the relationship here is the measure of a, I'm just going to type this in again, the measure of a central angle is equal to the measure, or is equal to the, we'll say, well, the measure of or equal to the intercepted arc. All right, now what that means is, let's look at this example down here to the bottom right. All right, now they tell us right here that this angle right here, angle GFE, is 95 degrees. Now, because that's located at the center, that's a central angle. So what that means is, because my central angle is 95 degrees, that means my arc GE, is also 95 degrees. All right, so the measure of my central angle is equal to the measure of its intercepted arc. Now, one more thing, I forgot to mention this earlier, when we're talking about our minor arc, our major arc, and our semicircle. Typically, with a minor arc, you're going to use 2 letters to name it. So I'm going to put up here 2 letters. You're going to use 2 letters to name a minor arc. That's pretty common. All right, that's what you'll see throughout the most parts. So 2 letters to name either a minor arc or a semicircle. For a major arc, you are going to use 3 letters, and those 3 letters have to be there. It's like when we name our angle with 3 letters. You have to have 3 letters because it's going to verify and give you a specific order or direction to use when you are naming it. So for example, down here, if we look back down here at this example we were looking at earlier, this major arc right here. Now, if you remember, I called that arc ACB. All right, because if I just called it AB, I don't know if I'm talking about this direction right here, the small direction, or if I'm talking about the big direction. So that's why we use 3 letters, so we're much more specific in a direction. So ACB means I'm going this direction, whereas arc AB will be that smaller one. And then a semicircle, you can name it with 2 or 3 letters. So you could say 2/3 letters. And this is something you guys might want to put on there just so you can refer back to it. All right, so once again, a minor arc, less than 180 degrees, you use 2 letters. Major arc is more than 180 degrees, you use 3 letters. A semicircle is equal to 180. You can use 2 or 3 letters to name it. All right, so that's just talking about the different arcs. And really, those are the 3 concepts we're going to be talking about today. Minor, major, and semicircle with our central angle. All right, now, the measure of it, this next blank right here, the measure of a major arc, oops, let me learn how to spell here. Major arc is 360 degrees minus the associated minor arc. So using that definition there, let's look at this other example we just started a second ago. All right, so we found out that arc GE, it's a minor arc, notice 95 degrees, less than 180 degrees, so it's a minor arc. If my minor arc is 95 degrees, then we'll get excited here. All right, we'll do this one. My minor arc is 95 degrees, and that means the associated major arc, which is all that right there, which would be arc GHE, that's a major arc, so I got to use 3 letters, would be 360 degrees, 360, minus my 95 degrees. If I know my whole circle is 360 degrees, I know this piece is 95, that means this major arc is going to be whatever's left. So in this case, 360 minus 95 degrees is going to give me 265 degrees. 265. So that means the measure of arc GHE is going to be 265 degrees, and it's actually right up here. So I actually didn't need to write that at all. All right, so that's just really, again, the concept that we're going to be looking at today. Minor arcs, major arcs, semicircles, and central angles. So once again, your central angle is equal to its intercepted arc. So the angle GFE was equal to 95 degrees, which means arc GE is 95 degrees. And then my major arc is 360 minus that particular minor arc, which would be 265 degrees in this case. So let's look at a couple examples dealing with that. All right, first one. All right, tell if each is major arc, minor arc, or semicircle, and then find the measure of each. Now, I found it easier sometimes to look at my picture and go ahead and fill in my missing degrees. Then I can go through and find my different arc measures. All right, so for example, KM right here. KM, if you guys look carefully enough, it's a chord. Segments are on the circle, or the endpoints are on the circle. It goes through the center point, which means KM is my diameter, which means this arc right here, arc KM or arc KLM, is a semicircle. All right, which means it adds up to 180 degrees. So if this angle right here is 125 degrees, first of all, it's a central angle. It's at the center, which means arc LM right here is also 125 degrees. Notice, less than 180, so I can use two letters, so arc LM. If that's 125 degrees, then the way I find this angle right here, angle KJL, is I do 180 minus 125. And if I do 180 degrees minus 125, I get 55 degrees. So this angle right here, trying to make this small enough and legible, that angle right there is 55 degrees, which means this arc right out here is also 55 degrees. All right, now, because earlier we said that arc KLM is a semicircle, that means this bottom arc right here is also a semicircle, which means it has a degree measure equal to 180 degrees. All right, so now I filled in everything. I guess you could say this is a central angle of 180 degrees as well. We filled in all my different pieces, so now let's go through and let's see what we get. All right, so first one, it says the measure of arc KL. Well, here's arc KL right here. We already found it. We found it to be 55 degrees. So 55 degrees. All right, so the next one, arc KLM. So K, so we're just kind of going on K to L all the way around to M. All right, so we said earlier that's a semicircle, which means it's 180 degrees. And I guess we also need to identify this first one, because it was 55 degrees, we're going to call that a minor arc. M-I-N-O-O-R, just one O actually. All right, and then arc KLM, because it's equal to 180 degrees, I'm just going to put here a semi. There we go, semicircle. All right, so the next one, arc KML. Now be very careful to follow the path that it's asking for. So this one says go from K to M to L. Now, I can't go from K to L to M because that's not the order. They want me to go from K. I'm going to use a different color here. We'll use this one. All right, so I want to go from K around to M and then around to L. So it's almost a full circle. However, it's not. It's only part of a circle. But if you notice, that's more than 180 degrees, which is going to be a minor arc. So that means I can take and either add up. All right, so I can add 180 plus 125. That will give me that piece. Or I know the whole thing's 360 degrees. I can take 360 minus 55. Either way, you should get the same part. All right, whoops. Oh my goodness. There we go. Let's try this one more time. All right, so earlier we said this is a semicircle. All right, so arc KML, I can either take 180 degrees, and let's see if it's easier, more legible this way. I can either take 180 degrees plus 125, which if I did that, that would give me 305 degrees. So let me just expand that a little bit, make it all fit. There we go. All right, so that's one way I can do it. Or the other way I could do it, like we said before, is I could take my 360 degrees, because that's what the whole circle is, and subtract off the 55 that I don't want, and I also get 305 degrees. So either way I do it, you're going to get the same thing. So arc KML is 305 degrees. Now, because that's more than 180 degrees, that's going to be a major arc. So we'll kind of add that piece underneath this. I'm going to learn how to spell again. There we go. So that's a major arc. A little bit easier to read. All right, so there's part C. Now, part D, arc ML. All right, so let's go over here and look at arc ML, which we already have. All right, arc ML from M to L. Notice they only use two letters, so it's more than likely going to be a minor arc. So ML from M to L, we already said was 125 degrees. All right, we're going to go back to this. I'm going to say 125 degrees. And because it is less than 180 degrees, we're going to call it a minor arc. There you go. Cool. All right, so once again, we're looking at central angles, minor arcs, and major arcs. All right, so let's look at another example. Now, this one is actually using a circle graph. All right, so we're going to be able to use the same concept here because you notice it kind of looks like a pie chart or a circle graph. Either one are the same thing. All right, but notice I've got a central angle here and I've got a bunch of other little angles branching off. All right, so this is actually talking about the different types of grass planted in a neighborhood. All right, some of you may or may not know what type of grass you have at your house. Most types of grass in Georgia, just for a little knowledge for you, most of it is either Bermuda or fescue. Some of the fancy places maybe have zoysia, which is a type of Bermuda, a fancy type of Bermuda, or it's centipede grass, which is a little bit more rare. Kind of looks kind of like a centipede, hence the name centipede grass. But anyways, what we've got here is they want us to find, I'll highlight it for you, they want us to find the measure of arc KLF. All right, now if we're looking for that, the measure of arc K to L to F. Now notice that's this section right here, which represents that 65%. All right, now notice I've got all percentages here, 8%, 7%, 20%, 65%. All right, now those should all add up to be 100%. So if I took the 65 plus the 20 plus the 8 plus the 7, all right, that's 100%. So that adds up to 100%. So we've got our percentages there. All right, but now what I need to do is I need to convert those percentages to angle measures or arc measures. That's the only way I'm going to be able to find the measure of arc KLF. That's the only way. All right, so what did we say earlier that the degree measure of our entire circle was? Very good, 360 degrees. So if I can take my 65% and multiply it by 360 degrees, I want 65% of 360 degrees, that means I'm going to be multiplying. Now, if you guys remember, 65% is actually 0.65. 65% is 0.65, so take that times my 360 degrees, which, there we go. If I take my 0.65 and I multiply it by 360 degrees, that's going to give me 234 degrees. All right, so that means the measure of arc KLF is 234 degrees. Now, if it asks for it, which it doesn't here, but if it asks for it, that means it's going to be a major arc. A majority of the grass in that neighborhood is 65% centipede grass, or 234 degrees of this particular circle chart. All right, cool. All right, I think we're getting close to being done, and we got a couple more slides. All right, so what I want you guys to do real quick is I want you to try and find what I'm asking for right over here. So the first one is the measure of angle FMC, which will be a central angle. All right, so that means we're going to be looking at, so we've got F to M to C. So we are actually going to be looking for this angle right here. Notice that includes pop, that includes country, and we've got a little R&B. So we got a 9% here, a 10% here, and 11%. So I want you guys to take a quick second and see. So it represents 19, 11, so it's 30% of this pie chart. How much of that 30%, what's the degree measure of that particular arc? So y'all take a quick second and figure that piece out. And then also find the measure of arc AHB. So A to H all the way around to B. So you're also going to find the measure of that arc right there. So y'all take a quick second and check that out. All right, so let's take a look at this first one here. We're going to try and find the measure of angle FMC. All right, so like we said a few moments ago, it's going to be from here to M to C. So we've got another central angle here. So that angle is going to be the same as the measure of its intercepted arc. All right, now before we do anything, if you notice, just like the last problem, we have percentages again. All right, if we're going to try to find the measure of the angle, we've actually got to convert these percentages to degree measures. All right, so this will give me the measure of each arc, if I can add those together, that'll give me the measure of the intercept or the central angle. There we go. Central angle as well. So we're going to have my 9%. Let's go through. So we got my pop, 9%, my country at 10%, and my R&B is at 11%. All right, so we can do this one of two ways. We can either convert each of the percentages individually to a degree measure, or we can go ahead and add those together and convert that degree measure once. All right, so we'll do it both ways just to show you that both ways end up the same. So first, let's take each individual one. All right, so we've got 9%, so I'm going to put this right over here. All right, so 9%, if I convert that percentage to a decimal, that's going to be 0.09. We will multiply that by, if you guys remember, the degree measure of my entire circle is 360 degrees. All right, so when we do that, all right, if we take 9% or 0.09 and multiply it by 360 degrees, that'll give me 32.4 degrees. All right, so just the measure of my pop, my music sales, is going to be 32.4 degrees. All right, so we've got that one. All right, let's look at the second one. So the next one's country. That's 10%. So if we convert that to a decimal, that's going to be 0.1 or 0.10 times 360 degrees. All right, I won't put the degree mark just to be a little bit quicker. So if I take 0.1 and multiply it by 360 degrees, I get 36 degrees. All right, and my last one is R&B, which is 11%. So that's going to be 0.11 times 360 degrees. And that is going to give me, when I take 0.11 and multiply it by 360 degrees, that'll give me 39.6 degrees. All right, so that's what each of them are individually. Move this down a little bit. All right, so together, if I were to take each of those and add those up, so we got 39.6 plus 36 plus 32.4, that'll give me 108 degrees. All right, so if I just take this, we'll add those up. That now will give me 108 degrees. There we go. Excellent. All right, so that's the first way you can do it. Now that one's probably a little bit longer. The other way to do it is to take our percentages and add them up and then convert it once to degrees. I'm going to do that just over here on the other side. Let's take and erase those parts. All right. Maybe we won't. There we go. We'll keep it there. So next thing I want to do is add up my percentages. So I took 9%, 10%, and 11%, and I added those up. That gives me 30%. So the other way I can do this is I can take my 30%, which as a decimal is 0.3. So we've got 0.30 times the 360 degrees. And if I took that, you take 0.3 and multiply it by 360, notice you get 108 degrees. So either way you do it, you can take each individual one, convert it to a decimal, and then multiply, then add those up, or you can add up the percentages, convert that to a decimal, and multiply by 360. It will also give you 108 degrees. Alrighty. All right, so let's look at the second one. Next one we want to do is find the measure of arc AHB. All right, now if you remember from a couple slides ago, if I use 3 letters, it's probably either going to be a semicircle or a major arc. So let's look at that real quick. All right, so AHB, so I'm going to go from A over to H, and I'm going to keep going all the way around to B. All right, so if you notice, that's more than half the circle, so it's more than 180 degrees, which will mean it's a major arc. So once again, 3 letters typically means a major arc or a semicircle. All right, so I want to find the measure of that entire arc, which means, once again, I'm going to have to convert percentages to decimals and then convert those to degrees. All right, now there's a quick way and there's a much shorter way. All right, the quick way, I'm sure most of you guys want the quick way anyways, is if you notice, this much of the circle is what we're talking about here. All of this in here. All right, so if you notice, the piece that I want to disregard, or the piece that I don't want to include, is this 25%, this rock and roll piece. All right, so the quickest way is to just find the degree measure here for rock and roll and subtract that from 360. That's the quickest way. The longer way is to take each of these percentages here and add them up and then multiply that by 360. But either way, you're going to get to the same piece. All right, so what we're going to do is we're going to take my 25% here, which is 0.25, and we're going to convert that to a decimal and then convert that to a degree measure. So if I take 0.25 and I multiply it by 360 degrees, or it's a quarter of 360 degrees, that's going to give me 90 degrees. Now, if you look close enough, it kind of looks like a 90-degree angle. In this case, it actually is. All right, so if I know now that this particular arc right here, my rock and roll, represents 90 degrees, that means the remaining part of my pie chart or my circle graph should add up to 360 degrees. So the way we find that is we can take 360 degrees, or 360, and subtract off my 90, and that's going to give me 270 degrees. All right, the other way we could have done, which actually, now looking at it, it's actually about the same, maybe a little bit longer. All right, but the other way is just to take each of my percentages, my 26, my 3, my 9, my 10, my 11, and my 13, and add those up to a percentage, and then convert that to a degree measure. Now, the other way we know is we know the entire circle is 360, which the entire pie chart or percentages should add up to 100. So if I took 100 minus 75, or minus 25, that would give me 75 degrees. Or once again, I can add each of these percentages up. Now, if we do add each of those percentages up, they do add at 75%. So the other thing that we can do is I can take 0.75 and multiply it by 360 degrees. And if I take 0.75 and multiply it by 360 degrees, that's going to give me 270 degrees. So if you notice, either way I do it, I get to 270 degrees. So the measure of arc AHB is going to be 270 degrees. So most of these actually have multiple ways of going about solving them. It's just finding the way that you like best and go about solving it that way. All right, so we've got one more example to look at, and then we will be done with section 12.2. All right, the next one we're going to look at is just looking for more arc measures. All right, now we're going to talk about, it's called the arc addition postulate. Don't worry about knowing that it's postulate 11-2-1. I just want you guys to make sure you understand the material behind this particular postulate. All right, so what it's saying is if I want to find the measure of a larger arc, I can take two individual arcs and add them together. All right, so if I knew that arc AB right here was, let's just say it's 40 degrees, all right, and I know that arc BC is 20 degrees, then together the measure of arc ABC, or the measure of arc AC, since it's a minor arc, would be 40 plus 20, which would be 60. So this would be 40 plus 20, which happens to equal 60 degrees. So that's what the arc addition postulate says. If you just add up each of the smaller arcs, that will give you a larger arc. So let's go through and look at these last three pieces here, last three examples, and we will wrap it up. All right, so like we did earlier, what I recommend you guys do is go ahead and find all the missing pieces first, and then it makes it easier when you're looking for specific things. All right, so here we know that the measure of angle AOB, this central angle here, is 60 degrees. We know that the measure of angle BOC here is 82 degrees. And we know that the measure of angle COD is 100 degrees. All right, now I need to find this missing angle here, which is the measure of angle AOD. Now, if you guys remember, the entire circle is 360 degrees. If I can add these pieces up here, and then I can subtract it from 360, that'll give me the measure of that missing piece. All right, so if I take 360 minus 100 minus 60 minus 82, that gives me this missing angle right here to be 118 degrees. All right, now remember, because these are central angles, their intercepted arcs are also the same degree measure. So for example, the measure of arc AB would be 60 degrees. The measure of arc BC right here would be 82 degrees. All right, the measure of arc CD, guess what? It's 100 degrees. And then the last one, the measure of arc AD, is going to be 118 degrees. All right, so first thing we want to find is the measure of arc AC. Now, two letters, meaning it's going to be a minor arc, because if you look over here at your picture, you could go the measure of arc ADC, which is going to be more than 180 degrees, which means that's a major arc. So I want minor arc AC because they have two letters. So that's going to be your 60 plus your 82, which will give me here 142 degrees. So the measure of arc AC is 142 degrees. All right, so now if we look at the next one, the measure of arc ACD. Now that's 3 letters, so that's either going to be a semicircle or a major arc. Now there are examples where a minor arc is named using 3 letters, but that's very rare. Usually it's going to be 2 letters. All right, so let's just make sure it is going to be a major arc or a semicircle. So I've got A to C all the way around to D. All right. So to find the measure of our ACD, I'm going to take each of these pieces of 60 plus 82 plus 100 degrees. So those 3 individual smaller arcs add together to equal this major arc. All right, so if I add each of these up, take 60 plus 82 plus 100 degrees, that's going to give me 242 degrees. So the measure of arc ACD is 242 degrees. All right, so now let's look at our last example here, the measure of arc AD. So once again, it's got 2 letters, so more than likely it's a minor arc. It could be a semicircle, but let's just double check. So A to D. Now if you notice, if I went from A around this way following the red path, that would be a major arc. And we just did that one, A to D, but again, we had to have a 3rd letter because it's a major arc. So 2 letters means minor arc, so A to D, we've already found that measure to be 118 degrees. So there you go. That's it with central angles, minor arcs, major arcs, and semicircles. All right. So if you guys have any questions, please let the sub know. Please go see another teacher. If there's anything that's confusing or you do have questions about, please make sure you find the answers. Hope you guys have a wonderful day, and I will talk to you guys soon again this week. See you guys.